Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be dealing with polynomial equations. Z squared equals 2z minus 5, 2z or not 2z, that should be a C or a B. Anyways, we're supposed to evaluate z to the fourth plus 12z. So based on the z values we find from the first equation, we're going to evaluate the second equation. So second one actually depends on the first one. Okay? And I'll be presenting two methods. I guess you could do this in more than two ways, definitely. When it comes to polynomials, there are actually very many ways to solve problems. But let's start with the first method. So for my first method, I'm going to solve an equation because solving equations are fun, especially the quadratic ones. Let's put everything on the same side. And then I want to solve this quadratic. How could I solve it? There's two ways to do it. So I can talk about a 1a and a 1b. I should have done this second method. But anyways, we've done 2b already. So what do? We can go ahead and use the quadratic formula as an alternative, negative b, plus minus the square root of b squared 4 minus 4ac, which is 20, and then divided by 2. 4 minus 20 is just going to be negative 16. Square root of negative 16 is 4i or negative 4i. So we're going to write this as 2 plus minus 4i divided by 2. And of course, it can be simplified and written as 1 plus minus 2i. So those are the solutions? That's it? No. We're not supposed to solve for z. We're supposed to evaluate an expression that contains powers of z, which is this one. So let's go ahead and evaluate z to the fourth plus 12z. But what is z to the fourth? And which z are we going to choose? The answer, it does not matter. That's how the problem is designed, you know. It's kind of like, what is it called? Contrived that way. Okay. So let's go with the positive one because it's more positive. Well, there are no signs. Well, let's just pretend this is a positive number. 1 plus 2i. So we're going to go with the plus sign. And I want to raise it to the fourth power. If you don't like the binomial theorem with the fourth powers, you can square this and then square that again. Let's square this. That gives me 1 plus 4i minus 4. Remember, 2i squared is 4i squared, which is negative 4. This is negative 3 plus 4i. 3, 4 triangle, right? That should be familiar. And then square this one more time to get the fourth power. And this becomes 9 minus 24i minus 16. 4i squared is 16i squared. And that becomes negative 7 minus 24i. That's interesting because 7, 24, 25 is another Pythagorean triple. Anyways, too much geometry. Now, this is z to the fourth power. Okay. And what is z? We know it because we went with 1 plus 2i. So let's go ahead and plug it in, right? We're going to replace z to the fourth with negative 7 minus 24i. And replace z with 1 plus 2i. You see what I see, hopefully. This becomes negative 7 minus 24i plus 12 minus 24i. And yes, 24i cancels out. Negative 7 plus 12 is equal to 5. Therefore, the answer is 5. We had a negative 5. Now we have a 5. Interesting. So the answer would be z to the fourth plus 12z equals 5. That's what we were looking for, and we found the z value. Now, if you tried the other route, 1 minus 2i, you would get a different square, different fourth power, and of course a different z, and it would give you the same answer because it doesn't matter. And you'll see with the second method why it does not really matter. Okay? Let's go ahead and take a look at the second method now. So we have z squared equals 2z minus 5, and we're supposed to evaluate z to the fourth plus 12z. Numerically. Didn't say that, but hopefully that was understood. We're supposed to find a numerical answer. Otherwise, you can find a bunch of different things, right? But we can all agree on a constant, hopefully. Now, with the second method, I'm going to manipulate this as a polynomial. So I have z squared. I need z to the fourth power. So what does that mean? Well, it just means that to get to z to the fourth from z squared, you just need to square both sides. So let's go ahead and do it. If you square z squared, you get z to the fourth. And then on the right-hand side, we get 4z squared minus 20z plus 25. But notice that z squared is the same as 2z minus 5. So I can replace z squared with that again, right? So that's something that you got to keep doing with this method, but it's not going to take too long, hopefully, right? You just got to keep doing it. So in other words, we're linearizing our expression. It's given as a quartic, we're linearizing it, okay? And we're almost done. So from here, we're going to get the following. Z to the fourth on the left-hand side. Let's go ahead and distribute the 4. That's going to give me 8z minus 20 minus 20z plus 25. Okay, let's simplify the right-hand side by combining like terms. 8z minus 20z is negative 12z, or some people call it minus 12z. I don't think there's an agreement. Negative 20 plus 25 is going to be positive 5. Okay? Well, how's that going to help? What were we trying to find? What was the expression? Oh, we were trying to evaluate, pretend you don't see the first method. We were trying to evaluate z to the fourth plus 12z. Okay, so that's what we're looking for. Wait a minute. I already know that z to the fourth is equal to negative 12z. So all you have to do is add this to both sides and you'll get the answer. Okay? So if you do add this to both sides, you're going to get 5, which is the answer. So notice that with the second method, we didn't have to find the z values, but we kind of expressed z squared in terms of z, and then z to the fourth in terms of z, and then we plugged it in. Of course, this problem was designed in such a way that that expression z to the fourth plus 12z would be numerical. It will be a constant, okay, no matter what the z values are. And of course, by using the same method, by using the same formula right here, you could find z to the third, z to the fifth, z to the seventh, any higher power. But of course, if you're looking for very high powers, then you want to get a good pattern. Anyways, this brings us to the end of the video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.